Hello everybody. Welcome back to my YT channel. This is again, I'm a singer eternal voice or YouTube content creator. So let's go back with vlog number 2. Okay, for the topic of chemical equilibrium calculations and problem solving. So I have number 2. Okay. So in this particular question, we have 4 what are being asked. We have the equilibrium constant of the concentration expression. We have the initial concentration, the changes of concentration, and the equilibrium concentration. So it's always like that, guys, in this particular topic. And then mostly it should be tabulated through the table, okay, like that. And we need to use the eyes technique. I meaning initial concentration, C the change of the concentration, and E is the equilibrium concentrations. Okay? Something like that. So the K term here is very easy. The word equilibrium. Always have like that. At least one time or 2 times or 1 time only minimum. Okay, because if it is not mentioned, it could either be another term will be used, but that's unusual. Okay, usually have equilibrium term. See here. One equilibrium term here, and then the other also, it's only one. Okay, it's seldom and rare that there is no term equilibrium, so could that be related to chemical equilibrium topic? You get the point? Okay, unless, take note, unless the key Q is given because it's understood to be the equilibrium constant, even if the term equilibrium is not written or declared in the question. Okay, because small letter k would mean equilibrium constant. Okay, especially if it involves chemical reaction. Or small letter k in science, that's represented to any kind of constants. Okay, but if there is a chemical reaction, technically that is equilibrium constant. It could be equilibrium constant of the acid, equilibrium constant of the base, equilibrium constant of water, which is the auto-ionization equilibrium constant of water, something like that, okay, or equilibrium concentration of the products, like that, okay, and you will know that. That's Kp for the partial pressure equilibrium constant, okay, so don't be confused with the Kp products and the Kp partial concentration. Anyhow, it will be mentioned in the problem also, okay, you get the point? Something like that, okay. A 1 mole sample of NaOCl was placed in a 2-liter reactor, wow, reactor talaga, and heated to 257 degrees Celsius until the system reached equilibrium. That's very clear, right? Until the system reached equilibrium, meaning to say the rate of forward reaction will be automatically equal to the rate of the reverse reaction. Okay, meaning there's no changes in the concentrations when this equilibrium has been reached. Okay, something like that. The contents of the reactor were then analyzed and found to contain 0.056 mole of chlorine gas. Okay, something like that. Take note the phrasing of the sentence. The contents of the reactor were then analyzed and found to contain 0.056 mole. English matters here because some students, some examiners will interpret this as an initial concentration, and some also know that all will interpret this as an equilibrium concentration already, and some also will interpret this as a change in concentration siya because it's not, the terms are not really that clear, and you have to understand the contents of the reactor were then analyzed, meaning to say it has been removed and extracted already. When you remove and extracted already, isolate, that is already the result or the product you'd been extracting for. Okay, so that would mean the equilibrium concentration because it's in the final stage, something like that. Though it has not been mentioned here. Okay, because this sentence is different. Okay, from the other sentence. Okay. Okay, like that. Calculate the equilibrium concentration constant at this temperature. Meaning to say, at 257 degrees Celsius because there's no other temperature given. Okay? Why I must say this? Because temperature matters a lot. Okay? Because temperature has the highest influence to change the concentration of the reaction or your rate law or the rate of chemical reaction. and also the concentration. Okay, as we remember that always, temperature has the highest influence to affect your concentration, rate of reaction, rate low, and rate of chemical reaction. It's not the heat. Okay, it's not the pressure, it's not the volume, it's not the number of moles, it's not the density, it's not the viscosity, it's not the universal gas constant, it's not the specific capacity, it's not the volume, but it's always the temperature. Now, temperature is very close to heat. Okay, now it's not heat is the answer. Why? Because heat is a specific heat, it's not cold. Okay, but temperature could either be cold, could either be heat. So that means temperature is the highest influence, not the heat. Okay, because sometimes it will be included in the choices. For example, I remember, yes, it came out in the board examination, says what of the following parameter, operating parameter, has the highest, okay, influence that affect the factors of the solubility of the concentration. A, temperature, B, pressure, C, heat, D, adding a catalyst, E, adding an intermediate, something like that. So multiple choice. Okay, it's very clear that it's either heat and temperature, because if you heat that, of course, it will react more. It will have a fast reaction because it will lower the activation energy. Because there's no chemical reaction if the activation energy will not be lower. Because that is the lowest temperature given at a certain equivalent kinetic energy so that chemical reaction will occur. Okay? Something like that. So, could either be heat and temperature, but temperature is the answer. You get the point? So, usay, butakan pa ganun kinetic energy. Because kinetic energy also influence the chemical reaction. Okay, the more the kinetic energy is high, the more the molecules are bombarded and collided in the certain container in order the chemical reaction to proceed. Even though you will not add a catalyst. You get the point? As long as you increase the kinetic energy. So the only way to increase the kinetic energy is to apply heat. Right? And by applying heat, you change the temperature. But in the highest level, not on the lower, because the lower will be cold. Okay, like that. So that's why the answer is temperature. Could either be lowered or increased, like that. Okay, not the heat and not the kinetic energy, but they are closely related to each other. Okay, you get the point. But if you try to rank this one, then it's up to you. Ranking will follow. But normally, if the question will say like this, what are the factors that influence the rate of chemical reaction? So you must answer the kinetic energy, activation energy, the heat, and the temperature. All of the above. Something like, because not too much with pressure. Even though you will apply a lot of pressure, it doesn't change the concentration that much. So it will not have an effect. Something like that. You get the point? Oh, that's it. That's the principle behind for this. Okay, now calculate K as the temperature. The equation for the decomposition of NaCl to NO and chloride gas is as follows. Oh my gosh. 2 moles of NaCl gas, reversible reaction. Produce 2 moles of nitrous oxide gas plus chlorine gas. Oh, we are very, very blessed. Because the chemical reaction is given already in the problem and question, and then it is also perfectly balanced, and then it shows 2 arrows, the reverse rate of reaction and the forward rate of reaction, and it's very, very easy to formulate the formula out of this. Okay, so how can we get the Kc for this? Okay, Kc is gonna be like the concentration of the products over the concentration of the reactants, each raised to the power coefficient. Okay? Or number of moles. So, well, ako sa libot akong coffee kay mabugnaw. Char. Okay? Coffee, everyone! Nakakaloka. Okay, nakurot akong coffee. It's about time to continue the discussion. Okay. Ay, nako mga palangga. Okay. Let's take down here the important K points. Let's take the temperature first because I have a very, very restricted and limited space. The dimension of my whiteboard is very, very limited. Okay, surface area, length times width. Okay, so I cannot expand more my writings or whatever, so I have to erase something. Okay, so the temperature is 207 degrees Celsius. mga palangga. And then, the reactor were then analyzed and found to contain 0.5 CO2. Okay, concentration of chlorine, like this, okay, bracket or parenthesis is equals to 0.0056 mole. But take note, guys, this is also another trick. Okay, were then analyzed and found to contain 0.056. This is not yet the concentration. Okay, this is still the number of moles. So we need to divide that to the volume of the container itself. Okay, what is the container? 2 liters. Okay, so we need to say 0.056 moles divided by 2. Ganon. So it will become now moles per liter or the molarity. Okay, the molarity of the chlorine gas at equilibrium. Okay, so this is our data. Okay, now is there anything else for this? And I have to erase already. Okay, initial concentration of NOCl. I have to put here in the reaction. I have no space anymore. So 1 mole of NOCl. So we have also a volume of 2 liters. Then it will be divided to 2 liters, mga palangga. So it will become 0.5 molarity or moles per liter. We will just use the molarity, okay, not the moles per liter, because it will confuse us too much quantities. We go to the simplified one, okay, something like that. It's the same thing. I have to erase this problem already. There's no such data anymore. Okay, mga palangga, okay na siya. Okay, erase. Okay, solution proper. Okay. Ganon. Okay, mga palangga, get your blank sheet of paper and take down notes if you want also. Or just write the K terms, K points for your learning outcomes after this vlog. Okay, now going back to the proper discussion, we need to incorporate the data here in our table. So this is called initial rates determination table. Okay, initial concentration and initial determination method. What we call that, because this is related to chemical kinetics, okay, the study of chemical reaction rates to determine how fast or slow the chemical reaction. So that's the purpose of chemical kinetics. That's why we need to get the rate laws, the rate of chemical reaction, how fast is that, dependent on time. Okay, RATE rate. It's related here. That's why we need to discuss this before going to chemical kinetics later on. Okay, ganon. Now, so I have this reaction. Okay, I have to put my Kc expression. Okay, Kc is equals to the concentration of the products, nitrous oxide gas, raised to the power 2 because this is the number of moles. Okay, times oxygen gas, there's the number of moles, so raised to the power 1 or the same, nothing. Okay, over the reactant NOCl raised to the power 2, because 2 is the coefficient, raised to the power 2. Now substitute values later on. We cannot proceed yet the substitution or plugging in the values because we don't have yet the other equilibrium concentration. We have already chlorine gas, but we don't have the NO and NOCl. That's why we need to tabulate. Okay, now like this, draw a table, something like that. This is not yet a graph, huh? Okay, the graph is very important to interpret how valid our answers really is, that we can match to the reality, what's going on, to the behavior of the gases or whatever, to relate the similar relationships. But table is not interpreting. It's not an interpretation of how you comprehend the behavior. It's just like putting that one in order we can understand what to put in the formulas, equations, like that. Okay, there's a difference between a table and a graph. Okay, so it doesn't illustrate the behavior or the properties of the chemicals considered in this chemical reaction. Okay, only putting the data so that we can solve properly what is being required. Okay, like that. So we have now the table. I have here, we have 1, 2, 3. So we have 3 elements or compounds. Basically, 2 elements and 1 element, pure gas oxygen, and 2 elements, NO and NOCl. So we need to put the table. We have 3, so 4 columns. Okay, divide this for 4 columns. Why I said 4 columns? Because we need to put first what is the description? Okay, description. This is the I, initial concentration. I, initial concentration. The unit is expressed in molarity. So capital M. And then number 2, second row, will be the capital C, meaning changes in concentration during the chemical reaction. Okay. And we have the equilibrium concentration during the final stage of your chemical reactions, what will be produced, and you have to collect that in the laboratory so that you can obtain what are the results or what are the compound elements that you are desired. Okay, something like to be used in your analysis and tests. Okay, something like that. And now we have here in OCL, mga kapatid, mga palangga. Okay. Now, in O, put that in a table. This is for easy understanding. Okay, because we cannot solve, very rough without understanding in a systematized way. Okay, like that. So, initial concentration of NOCl, look at the chemical reaction. Okay, we have. Okay, now, we have initial. 1 divided by 2 is 0.5. So, put the 0.5 here. I don't have to put the unit because it's understood all our molarity or capital M, moles per liter. Okay, now, in O. So in O, initially, there's no concentration given in your combination. In your decomposition reaction, you decompose this, meaning you heat, something like that. Because it will not decompose if you will never apply heat. Okay, how can it decompose naturally? Okay, something like that. You get the point. So we have nitrous oxide is 0. Ganon. Oxygen gas also has no initial concentration. So 0, like this. Changes, meaning the changes, it occurs. Okay. Now the changes will be basing now on the chemical reaction. You get the point? Like this. Okay. What are your changes for NOCl? Okay. Other instructors will just put there the 2x. No, it's not like that because we need to explain what's that x all about. Okay? Go very fast and like the 2x, 3x, and the students don't know what does x all about. This x, we let that x as our unknown concentration that change when the reaction occurs. Okay? Like that. X is the unknown concentrations of the products and reactants that will be happening during the chemical reaction takes place. That's why we need to let X as our unknown concentration. There's a purpose behind. Okay? It's not like that 2x, 3x, like that, and then straight, and then tomorrow, guys, assignment, something like that. So the students will confuse. What's that all about? What's X all about? Something like that. Though it's an advantage for the students because they will have their initiative to study more. Okay, that would be the most likely the case. If the instructors cannot explain very well, they will have efforts to do by themselves. Okay, to have an effort because they cannot understand very well the instructor's discussion. There's also an advantage for the students because it teaches them to be independent. But since we are, we are an educator, something like that, and a mentor, we need to do what's really the thing should be. Ganon. Okay. Now we have the concentration. So we have X. I let X. Okay. So if we have X unknown concentration and we have 2 moles of NOCl, this will become 2 times X. Okay, ganon. Okay, so 2 times X. And then guys, this concentration, okay, if you remember the theory in physics between scalar quantity and vector quantity, remember that one? What is a scalar quantity? What is a vector quantity? What is the difference between a velocity and a speed? Although they have the same unit, meter per second, something like that. It's more on the orientation or direction, like that. Magnitude is the unit, and then direction, it could be north, south, west, forward, backward, okay, downward, curvature, hyperbola, gaganan, okay? Or whatever, or let us say negative, meaning negative, going backward, still the same, going downward, negative, upward, positive, like that. So in chemical reaction, we denote plus and minus. Okay, if the concentration will reduce somewhere along your chemical reaction, that is negative. Okay, now if your concentration will increase somewhere in your chemical reaction, that is positive. So we have negative 2x. Why? Because your product will decrease during the chemical reaction because it will give sum of the concentrations to the products, or else it will not proceed the chemical reaction if this reactant will not give his or her concentrations to the product. Okay, you got the point. That's common sense. Okay, and then now NOx also 2x because NO has 2. You always take note the number of moles of the coefficient because it matters a lot. Okay, it's gonna be 2x. And what is the vector quantity? That is positive 2x because the concentration of NO will increase when the chemical reaction proceeds. So positive 2x. Other instructors don't put plus and minus. It should be emphasized really. As I told you guys, this is vector quantity, not scalar. You get the point? Direction and orientation, where this chemical reaction goes, like that, is very, very important. How fast this reaction, how slow this reaction, and that is vector quantity. Anything quantities in science, as long as there's an orientation and direction, whatever, directed to the top, to the bottom, to the left and right, and then taking the, the roundabout, whatever, north, south, east, west, and ganon. So that is vector quantity, okay? Something like that. Here, that's positive, meaning the concentration of the NO will increase somewhere along the way if the chemical reaction will start, something like that. And now we go also the oxygen gas. We need to let the X in the product. Yes, of course, because there's no number of mole. That is only 1, equivalent as nothing, but we need to have 1. So 1 times X is equals to X, right? Ganon. So plus also, because it will increase the same as nitrous oxide. Okay, like that. I remember chemistry lecture really, guys, they don't put sign. Really, okay? Anyhow, that would be okay also to let us independent. Okay? No problem. Okay, equilibrium concentration. Okay, like that. So we need to add the initial and the changes in the equilibrium because the equilibrium has been reached. Okay, you get the point. If it hasn't been reached, then you have to add because that's like this. So 5, if ganon is equals to negative 2x because you are equating that one. This is an algebraic linear expression. I'm just showing you why the equilibrium will be like this. Add like this, blah, blah, blah. Because this is an equilibrium. So 5 is equal to negative 2x. And then, if in equilibrium, the result is 0 because you add the reverse reaction and the forward reaction, then it will equal to 0. The other one is negative, of course. Something like that. It will become, okay, 5 plus 2x is equals to 0. And then transpose, it will become 5 minus 2x. Okay? Because this will be in math, the positive 2 will become negative. Okay, that's why 5 minus 2x. Okay, we will put here 5 minus 2x. Meaning to say, guys, this is 0.5, so not 5, 0.5. Okay, sorry. Nalipat na dyan akong mata. Okay, so 0.5 minus 2x. Okay? Guys, to be honest with you, ang kasagaran akong sayop sa solve problems is the way how I write, the way only the writing, but I know the flow of the problem solving, but the problem in me is I'm taking too fast in calculations and then too much erasures, something like that. That's why it made me wrong. Okay, so be careful also. Do not follow me. Okay, just manage that by yourself to make it clear, clean, and then average momentum. Average, what do you call this one? The time in your calculation, like that. You have to take a little bit slow, not too fast, not too slow. In the average. Okay? Like that. Nahugaw kaya ako mga solution, guys. Okay? So, I can say also if my solution is very clear, and then I think it will be more scores that I'll obtain after. But it doesn't happen to be like that. Okay? At least I passed. Okay? Something like this. So, 0.5 minus 2x. And then, we have 0 plus 2x and 0 plus x. Okay? Guys, in my own experience and confession, it is the basic foundation that made you pass in different examinations. It's not your intelligence. It's not the way you are very, very good or densely stirred. It's not. Foundation. Okay, starting from the elementary, grade school, high school, like that. You remember all the theories, lectures, and principles accumulate in your brain cells. Something like that, especially the basic formulas. The basic formulas of science are already discussed in grade school level or elementary level, density, like that, force. Okay, you remember that one? So, and then a lot of conversion factors. There's also conversion of feet to meter, like that, feet to miles, blah, 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 so on, so centimeters to blah, blah. It's already discussed in grade school level or elementary level. And then if you remember that, then there's no problem when you go to high school. And you remember the topic in high school, you should remember in college. All you have to do in college is to add more, like that. But the basic foundation is there, just like building a bridge. The foundation is strong, then the bridge will not collapse. You get the point? Okay. It will sustain for a long period of time. If the foundation, the strength of the bottom foundation of any infrastructures are very, very stable and strong. Okay? Right? And then we need to determine the center of gravity or the centroid in our calculation and strength of the materials, I think, right? Or engineering mechanics. Something like that. Okay, now going back to this particular problem, we need to substitute now our concentrations chupa-chucho. Okay, we have now here. Okay, substitute values at mga palangga. But, take note mga palangga. So we have the chlorine at equilibrium. Okay, chlorine. And you have chlorine also here. We have say 0 plus X. Okay, 0 plus X, meaning that is in equilibrium. So that is equal to chlorine concentrations here because it is equilibrium of the concentration after isolating that in the products during decomposition chemical reaction. Now, divide 0.056 to 2. Calculator, please. That would be your equilibrium concentration. Ganon. Okay, mga palangga. Okay, so it's gonna be like this. Okay. Okay. Namungot ko ano nga topic, guys, because this is the topic that I did not understand very well when I was in college. Really, these blogs I have is the areas in which I don't really understand that much when I was in my college years, and I really need to expand more. And I said to myself, if I know this before, so my scores will be higher, right? Okay. Though, to be honest with you guys, really, my aim is to become a top-notcher. When I take the board examination, I don't have to be hypocrite, okay? Like I'm telling you the truth. That's my aim before, okay? Before taking the board examination, I want to have a very, very high aim so that I can pass somewhere along the way, okay? And there's a lot of memorization during my time. Oh my gosh, I could not just imagine, okay? Almost 20 hours, or not 20 hours, or 10 hours study, okay? Like that, okay? More time and effort chupa-chucho plus memorization and practice problem solving and buying also latest reviewed books, especially in general engineering. Okay? I can manage the physical and chemical principles and chemical engineering, but I am I'm not that good in overall general engineering, the complete package of mathematics. Okay? I'm not very good on that. Okay? You get the point? Okay, now. Okay, it's gonna be like this, mga palangga. Now, NO, let's substitute now. So, going back to chlorine. Chlorine gas is equals to, calculator please, no, mga palangga. Okay, go. Ganon. Okay, divide by 2. Diba? Nag-compute mo, guys, wala. It's gonna be 0.028 molarity or moles per liter. Okay? Ganon. 0.028 molarity. Okay, this one. So it's gonna be 0 plus X is equal to 0.028 because this is in equilibrium. And 0 means nothing. So meaning to say X is just equal to 0.028. But if happens that there is a number of mole there, then problem. Okay, you will say 1 plus X is equal to 0.028 or 2 plus X. Because in oxygen in the chemical reaction, there's no number of mole. So we are just very lucky. Okay, if naasing 1 dali or 2, 1 as 2 plus X, then transpose. Ganon, but it's nothing there in the chemical reaction. Okay, you got the point. So X is 0.028 and this will be the X will be used of all the X's in this table because this is simply X. The concentration that we are trying to know or to let unknown concentration during our chemical reaction. So, because there's no other variable, only x, no y, no z, like that, right? In algebra, normally x, y, z, and are the variables always in linear equation. Algebraic linear expression. Okay? What do you call this one? Under the topic of polynomial. Right? Polynomial, binomial, monomial, like the trinomial, or whatever. Okay. Going back. So, let's do this. 0.02. Let's substitute now in our equation. NO is 0.5 minus 2x mga palangga. Okay? So, ganon. So, we have, ano man siya, no? 2x. Okay, minus na siya mga palangga. Okay, 0.2 times 0.028 is equal to 0.056. So, 0.5 minus, ganon chuba-chuchu, 0.056. So, 0.5 minus 0.056 is equals to 0.444 is our equilibrium concentration of your NO. Now take note guys, if you subtract this and the result is negative, your answer will be wrong. Okay? Like that. Okay? Because there's no negative of Kc somewhere along the way. There's no negative Kc. Okay? It's always positive. Though the exponent can be negative or positive, but there's no negative equilibrium constant. You got the point? So it should be positive always here. You got the point? Ganon. Okay, and then you should also take note that it is 0.5. Of course, it will become less. See, we have 0.44. So if that is 0.6 also, it's wrong. Because you're starting your concentration at 0.5. And then why it become up? So it deviates the theory and the principle and concept. And you should be extra careful. Okay? Because you start your chemical reaction, your reactant is 2.5, and then why it will reduce? It should be increased. Something like that. Okay, or bali, it should be reduced, not to be increased. Okay, since 0.5, it should be 0.4 down. Okay, because he gave the concentration to the products. Okay, so 0.44, ganon. 0.44 substituted in the Kz expression. Raised to the power 2, oxygen gas pila man. Okay, ang atong, this is chlorine gas, sorry, not oxygen gas. See, my writing is the problem, right? Chlorine gas, this is not oxygen gas. Most niya akong problema sa akong gas sa college pa ko guys. Akong mga suwat, masayop, ganun. Really. But I know how to solve that. Okay, I know the mechanism. Something like that. But only writing, clerical, too much fast, and then... I think this is the normal mistakes for the majority. I think so. Okay? But for me, too much. Kani akong, kuan ba, because I wearing also eyeglass when I was in college, akong mata mo blurred. Too much numbers, like that, and memorization, mathematical formulas. Ay, nakakaloka. Okay, so chlorine gas is equal to 0.028. Okay. Now, NOCl is 0.44 raised to the power 2. And then your NO will be 2x and you just 2x is equals to 0.0028. Then x is equals to 0.028 divided by 2. Okay. Ganon. So this is 0.028. Ganon chupa-chuchu. Diba guys, mga palangga? So 2x. No, this is 2 times x. The x is already 0.028. So it times na ko siya dito. So, okay? Ganon. Because I wondered why immediately I intercepted quickly. Okay, 0.056 siya guys. Okay? 0.056 diri ang numerator. Ganon siya guys, no? If you really understand, you can intercept very well immediately the mistake, right? Especially if it is technical mistake. This is technical mistake already because you did not do the correct way of solving the value of x, right? Okay, this is very basic. See? 2x. 2x. Kaya naman tayo x. It times na siya. It's not equal to x because that is not for chlorine. Ganun, diba? Okay. Ganun. Kc. Okay, mga palangga. Okay. Mga palangga. So, 0.444. Ganun siya. Chupa-chuchu is equals to... Ay, naku. Nakakalupa. 1971.36 and then 0.056 exponential to the 2. Ganon. Times 0.028 is equals to 8 and divided by 2, 0.197136 and then 4.45 ang atong case niya ni gayon na erase all. Because you have answered everything. See? 1 kc, nalina siya, 4.45. 2 initial concentration, o nakuha na nato tanan, chupa-chucho. Changes of concentration, nakuha na po na to, kaya naman mga value sa x. Equilibrium concentration, nakuha na, we already got it. So erase, because there's limited space in my whiteboard. Ganon. Erase everything. Okay, just remember the way how it is being solved and understand well. Okay? Now, Kc is equal to 4.45 times 10 to the negative 4. This is the equilibrium constant. Okay, ganon. And then if there will be an additional question like that, what is the pressure equilibrium constant? Relate tayo na akong equation nga. Kp is equal to Kc times universal gas constant times the capital T, parenthesis, raised to the power delta N, the change of the number of moles in your chemical reaction. Okay, even though there's no partial pressures given to chuchu, but we have the formula. Okay, like that. Okay, now theories, principles, theories. Okay, we attach how valid our answer really is. Okay. If we have a Kc is greater than 1, okay, the reaction will shift to the right or to the product. Then, the concentration has higher value of the M, molarity. So, let's prove it. Okay, we have 2, okay, we have 2x, which is 0.0284, that is in O, right? Ganon. In O gas. And now for chlorine gas, we have already 0.028. Okay. And we have 0.056 pala siya, guys. Wala akong i-memorize. Let's do it again. 0.056. Okay, ganon. Okay. So if greater than 1 Kc, it will goes to the product. Okay. But our Kc is not greater than 1. It is less than 1. Okay, less than 1. So, it will go to your reactant. And then, take note. Our reactant has a concentration at equilibrium at 0.44. Okay, 0.44. Okay? Add the 0.056 of NO1 0.028. Pila siya. Okay, 0.056 plus 0.028 is equals only to 0.084 at equilibrium. Adding both the products. Okay. Now, since you are saying that the equilibrium will shift to the left or to the reactant because your Kc is less than 1, in which our Kc is also less than 1 because it's raised to negative 4. Therefore, we conclude without question, technically our Kc is correct. Okay, because it is less than 1. So, the concentration will shift to the left or to the reactant, or the concentration of NaCl is greater than your products, even though you add the concentration of NO and the chlorine gas. So that's the basic principle and technique, or else you have a wrong answer. Okay, like that. This is the follow-up questions. Okay, like this. You get the point? And then it sometimes also, it will say, what will happen to your equilibrium quotient? Or reaction quotient. So that is also related to equilibrium concentrations. And you have to take, what will be happening to your rate of reaction? And then you have to establish also another formula. Ang imorgan tibanan guys, sa science and math, always the relationship of the formula. Relationship. If you understand that completely, you will get the valid answers. By having this, what will happen to other quantity? It will go up. It will remain constant. It will lower down. Then bingo. Then somewhere along the choices, you can determine A, B, C. Gamay man ni siya. Dalang ko ani. O taas man ni siya. Ang ana ragid siya, guys. You have to, you have to evaluate. Let's say, you should be smart enough. Something like that. Okay? You get the point. Okay? Sakto ba ang word smart enough? No, it's not really smart enough. You have to be observant. Okay? Like that. You get the point? Muna siya may tabo. Okay, now I will explain a little bit the reaction quotient. Okay? This reaction quotient thing is not also discussed very well in my college. That was 20 years ago. But due to my research, I have already the foundations because I'm a chemical engineer. Okay? But I researched more. It's gonna be like that. Maybe I was just sleeping when I was in my college years and the instructors are already teaching that one. Okay? Maybe I was sleeping or talking to my class or whatever. But I could not remember this reaction quotient really. Okay, so the reaction quotient is gonna be like this. Reaction quotient. So in math, what is a quotient? Okay, investigate the terminologies. Reaction is very clear. That's having element plus compound, or there's a combination of different substances. That's reaction. And then what is a quotient? A quotient is the result of the ratio. When you divide the numerator and the denominator, you have the quotient, and after that, if it is not really that exact, it has a remainder. Okay, remainder. And you have also the divisor and the dividend. If you use the elementary level symbol of division, such like this, and then you can, the divisor, the dividend, something like that. The divisor will be here, and the dividend will be here, and your remainder will be here. You will have a remainder if you are dividing not exact. Okay? But if it is perfect, there's no remainder at all. For example, 4 divided by 2. Your answer will be 2. Ganon. There's no remainder. And you know the divisor, you know the dividend, and your quotient will be your answer in the top by using the elementary level symbol of division operation in math. Okay. Now in higher math also, we have also the division noted not only like that, it is like this, line, numerator, let's say x numerator divided by y denominator. Let's say 2 over 3. So this is what we call as a division also. Okay? And another also symbol of division is in our calculator here. This one, like a cross, and there's a dot, 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 dot. So there's 3 symbols in division. In elementary level, like this. And then the ratio thing, and it's also in calculator, which is the normal division. Like that, tick, 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 cross. But there's a dot in the up and the bottom, and there's a line in between, a symbol like this. So 3 symbols of division operation in math. Okay. Now in higher math, you use the ratio, which is underlined, the numerator over the denominator. Now the answer for this is the quotient. That's why we say reaction quotient, because the reaction composed of the products and the reactants, and you have to divide the product over the reactants. That's why reaction quotient. And then the chemical reaction, you don't have to worry about the remainder because there's the remainder. Okay? You have to write everything there. Okay? As an exponent, whatever, chuba chuchu. Okay? Like this. That's why it's called reaction quotient. Ganon. So that's why you have also intelligent quotient, because that is the result of how you understand things around you. So that is quotient, or how fast you can quickly understand any academic information or whatever that you read in the social media or whatever you encountered in your daily experience in life, and you have to know then quick, as fast as you can always learn day by day. Then that is your quotient, the result and the product. Okay, something like that. Okay, so that is quotient. That's why we have intelligent quotient, emotional quotient, social quotient, ganon. Okay, so that's why IQ is intelligence quotient. And we have also EQ, emotional quotient. And we have also social quotient. If you are loving to be associated with different activities with different people, then you have a high degree of social quotient. Because social meaning the people, the community. Okay, the people around you in the environment. And if you say emotional, then you have the feelings of affection to others. You could easily give money for charity or generous to anybody who needs help financially. So you have a very high emotional quotient. Or let's say you play an affection to that certain somebody you love, something like that. So you have a very high emotional quotient. But in mathematics and science, it talks about IQ, intelligence quotient. Not only limited to the math and science, but also to other subjects as well. Okay, so English, like that, whatever. You get the point? Other minor subjects in your curriculum or your bachelor's degree curriculum that you take up in college. You get a point? Something like that. Okay, now nakasagot na tayo what is really a reaction quotient, and now we proceed. Okay, reaction quotient is just like this, represented with capital Q, mga palangga. Okay, capital Q, ganon. Okay, I have the reaction again, for example, hypothetical. Okay, usually guys, the instructors and the mentors and the professors will always have the hypothetical examples, and later on will be in reality, so that it could be applied in day-to-day life of students or any individuals. Okay, something like that. It should be put into practice what we've learned in the classroom instruction. Okay, for our self-improvement. Something like that. Okay, so there's gonna be like this. For example, A plus B is equals to C. Okay, this is unimolecular reaction. Unimolecular reaction is this? No, it's not. It's bimolecular reaction because we have A and B. Very fast. Very fast interaction, right? Okay, so A plus B is equals to C. Now, reaction quotient will be the concentration of C product over the concentration of A and B. Since there's no coefficient, all of them will not raise to something. Just one. One means nothing. Okay, ganon. Now, this is the reaction quotient. What is the relationship of reaction quotient to your equilibrium concentration expression Kc? Muna ni Ron, nakakaloka. Okay? You have to think this theory that the Q is inversely proportional with the 1 na number. Get the point? Di ba akong ibisaya ha? Okay. Di ba 1 ang imong basis sa kung Kc is greater than 1, less than 1. In this Q chuba chuchu, you think the reverse of the relationship of Kc and 1. For example, if Kc is greater than 1, di ba, it will shift to the product. But in Q, you will reverse, it shift to the reactant. So, if Kc is greater than Q, it will shift to the reactant. And the concentration of the reactant will increase. So always remember na, ang Q day ang number nga 1, ang bali niya nga result, mo na siya akong ikuan, ana. You should be observant like that also. It will help a lot in facing the examinations, okay? You get the point? So, it's gonna be Kc. If Kc is high, okay, than Q, then your concentrations of the reactant will increase, then your equilibrium will shift to the reactant, okay? Or your rate of, reverse reaction. Reverse reaction is the reactant, guys, ha? Forward reaction is the product. Okay, something like that. So, if Kc is less than Q, or reaction quotient, capital Q, then it will shift to the products, or more of the concentration of the product will be produced during your chemical reaction. Any questions so far, mga palangga? Do I talk very fast or not? Okay, that's it. Okay, so you have understand now what is a Q, what is a Kc, what is a Kp, initial concentration, you are ready to face examinations in this topic, in this kind of topic, right? Okay, the only issue here, guys, if it is rumbled and mixed already, sometimes, you cannot think very well. For example, it will be rumbled everything in 150 questions. All the topics, really, from first year college to 5th year college, something like that. And how can I do this? Okay, so sit back and relax. Go back to the basic foundation. Okay, like that. You get the point? What did you natin bigas ha? Ano naman ninyo? Basic foundations. Okay, theories, concepts, principles, basic foundations. Of course, there will be a basic formulas and equations there. Later na lang na mga complex, chuba chuchu. Because we are not aiming na summa cum laude, or whatever. Okay, something. It's okay to have a very high aim when you pass the examination. But what I mean, it doesn't have to be intelligent all the time or like that, just to pass. Okay, it's only your confidence, something like that. Okay, it's not really, or the mentality and perception that matters a lot. Because it boosts your confidence if you have a higher degree of positivity. Okay, something like positivism. The character and attitude of positivism. Wow, ganon. Really, okay, perception mentality, okay, of any individual can help also to pass certain examination. Because it will boost your confidence. Okay, enhance your confidence. Even though you are not really that good, whatever, okay, you get the point? Okay. And again, if you are not good in math, that is not an obstacle to become a licensed engineer. It doesn't really a necessity to become a good in math to become an engineer. Okay? You get the point? It will be developed and learned somewhere along the way. Because attitude and culture can develop to something in which you master that also within a long period of time. Okay? So it doesn't, as long as you have understanding and you have also good command in English language, then it's an advantage also. Get the point? Okay. If you like these videos, you can comment, you can like, you can share, and you can also click notification bell of I Am a Singer, Eternal Voice. And if you are not subscribing yet my YT channel, then you can subscribe now if you want also. Bye-bye, God bless everybody. See you later. O mga palangga, mga hitad kong palangga. Charot. Diba? Nakaloka.